Good morning, guys, from my childhood bedroom. Peep the American Girl doll. I want to show you guys a bunch of stuff for the Stoichiometry 1 practice, how to use the document, how to write the stuff on paper, using those conversions, example problems, all that jazz. So let's get started. I'm going to disappear, but hi, bye. Okay, so I have 5 problems in front of me, and they look very, very similar to the ones you have in your practice. First question is, how many moles of carbon dioxide are in 13 liters of CO2 gas? So I'm going to go and do this on paper or on my sketch pad, and then you'll see how I put it in the computer. So we're doing a conversion of liters to moles. And for that, we need to remember the conversion 22.4 liters is equal to 1 mole of any gaseous substance. Okay, so I'm going to start off by setting up my giant fraction. And I'm going to put the unit that I start with in this top left corner. So I know that it's 13 liters of CO2. I want to keep track of my substance, so make sure that's a habit and your unit. And then I know that I have my conversion factor, that there's 22.4 liters of CO2 in 1 mole of CO2. I've got liters here and here. This is the same thing as saying 2x divided by like 3x. The x's cancel in my fraction, so my liters cancels here. So that means when I multiply this out, I'm going to be left with the final unit of moles. So when I plug this into the calculator, I'm going to do 13 times 1 divided by 22.4. And that's going to equal to 0.58 moles of CO2. Okay, so then I'm going to show you how I type that out. So I'm just going to use the boxes as my fraction. For some reason, my subscript is on. So I know that it's 13 liters of CO2. And then I use the conversion of 22.4 liters of CO2 is equal to 1 mole of CO2. So then I just put my final answer in here, and that's 0.58 moles of CO2. So I don't have to do it on paper. I'm going to do it both so you can see both, but I know to multiply these top 2 numbers divided by everything on the bottom, and that's going to give me my final answer. Let's do another one. Now we're going from how many molecules of CO2 are in that many liters of CO2 gas. So we're going to need to set this up again. Hello, do my bidding. Okay, we'll erase all our ink. So in this one, we are going from liters to molecules. Now there is no direct path to do this, so we need to go from liters to moles to molecules. You're going to have that intermediary step of moles. So I set up my giant fraction. And I know I'm starting with 13 liters of carbon dioxide. I know that there are 22.4 liters of carbon dioxide in 1 mole of carbon dioxide. But I'm not there yet, right? So my liters cancel, but my moles are still there, but I want to get to molecules. So then I know that 1 mole of CO2 is the same thing as 6.022 times 10 to the 23rd molecules. And if I plug this into the calculator, I'm going to do 13 times 1 times 6.022 times 10 to the 23rd. And I'm going to divide it by 24 times 1. When you're putting this in the calculator, remember you don't have to type it out this way. You can put it as 6.022 E23, and you get that E from doing second comma on your calculator, and it's going to know what it means. So when I plugged this into the calculator, I ended up with 3.50 molecules of CO2. So that's how I do it on paper. I'm going to do it on the computer. Then, I think it's the subscript on a bunch of these. I'm going to need to do my 13 liters of CO2. And I'm going to divide it by 22.4 liters of CO2. And then that's going to lead me up to 1 mole of CO2. But I've run out of space, so I'm just going to add a column to the right because I know I need the extra step. And I know that 1 mole of CO2 is the same thing as 6.022 times 10 control plus to the 23rd molecules of CO2. That gives me a final answer of 3.50 molecules of CO2. I'm going to stop typing all of these now. You can kind of see how to do them and how to use it. And it's all set up for you. And I'm just going to go through the rest of the problems. So let's go back to my sketch pad. And now we're on number 3, which is how many grams of CO2 in that 13 liters. So this is another double step one. So we're going from liters to grams, but to get there, we have to use moles. Okay, so we're really going to go from liters to moles to grams again. All right, so we'll set up my fraction. I know I'm starting with 13 liters of carbon dioxide. I know that the conversion factor for liters to moles is 22.4 liters of carbon dioxide is 1 mole of carbon dioxide. I know that 1 mole of carbon dioxide has a value in grams. And that grams, remember, that is your molar mass. And that molar mass comes from your periodic table. So since this is carbon dioxide, that's a carbon plus an oxygen plus an oxygen. So my value for carbon is 12, and then oxygen is 16, and oxygen is 16. So that's going to end up being 44 grams per 1 mole of CO2. So now I can just put 44 grams here. And then that's going to be my factor right there. So liters cancels, moles cancels. I'm left with grams. When I plug this into the calculator, I'll do 13 times 44 divided by 22.4. Everything on the top multiplied together, divided by everything on the bottom multiplied together. And when I get my answer, it is 25.54 grams of carbon dioxide. I bet you don't think about gases having mass, but they do. Okay, great. So that's our final answer. Let's do another. The next one we have is going to be how many grams of NaCl are in 4 moles of NaCl. So we're switching substances. We were working with carbon dioxide before. Now we're going to work with sodium chloride. We want to go from grams to moles, and we have 4 moles. So we're going to go back to our workspace. And I have 4 moles of NaCl, and I want to know how many grams of NaCl that is. Since I'm starting with moles and going to grams, that's only going to be 1 step of moles to grams. I don't have to do any intermediary steps. So if I set this up, it's going to be 4 moles of NaCl at the top left corner. And I know that 1 mole of NaCl is equal to 58 grams of NaCl. And again, this is my molar mass that I got from my periodic table. I just did a sodium mass plus a chlorine mass. Okay, and then I'm done because look, moles cancels and I'm left with grams, which is exactly what I want. So if I have a final answer, that's going to be 232 grams of NaCl. Great. We've got one more, And that is how many molecules of NaCl are in 4 moles of NaCl. So we're going from moles to molecules. That's another quick conversion. Go to MySpace. So we're going to erase all this. Now we're going from that 4 moles of NaCl. We want to know how many molecules that is. NaCl. If we're going from moles to molecules, that means we need to use Avogadro's number, which is that 6.022 times 10 to the 23rd power. Because remember, 1 mole of any sort of substance, anything, is just 6.022 times 10 to the 23rd of that thing. Okay? So I've got 4 moles of NaCl. Set it up. I know that 1 mole of NaCl is equal to 6.022 times 10 to the 23rd molecules of NaCl. Notice that I spell out molecules every time because I don't want you to reduce down molecules to moles, because that's going to mean something different. So we don't want to abbreviate that much. All right, so when I plug this into the calculator, I'll just do 4 times 6.022 times 10 to the 23rd and divide that by 1. And that's going to give me a final answer of 2.41 times 10 to the 24th molecules of NaCl. See, my moles canceled. I was left with molecules, and that was my final unit. This was pretty quick, but hopefully you could kind of see how to use the worksheet, how to adjust it if you need to, and how to use those conversion factors. Please let me know if you have any other questions or need any help.